No, thank you so much, guys. Thank you, Dr. Kennedy, for inviting me, and thank you for you guys who are able to listen to me today. My name is Ndibuo. I don't know if you can introduce me, but I'm Ndibuo. I come from Limpopo in Pando. You can see with the colors here that I'm wearing. And I grew up there. I grew up in a small town called Milwani, and then I went to primary school there, and then I also went to high school there in a school called Milwi. And then when I was in high school, that's when I really got interested in computers. At the time, we didn't have programming at school, but we had computers. We were learning Microsoft and Microsoft apps, Word and Excel and everything. And then I was working as like a computer fixer, helping the teacher by that time. So I really got interested, and then I decided to study computer science. So come 2010, when I was supposed to be doing first year, I came here to Pretoria, went to the University of Pretoria to do computer science. And then it took me 8 years to complete a 3-year degree, but yeah, please don't ask me how that's possible, right? But fast forward to today, I'm the co-founder of Top Code. This is the logo right here. And then the co-founder, my other co-founder is Lerato. She's my wife. We work together in this. And the story around how we started Top Code is that when I started working around 2015, I worked at 3 small to medium companies, right? And then I worked at 3 banks as well, FNB, Standard Bank, and ABSA. But in one of the smaller ones, that's really where I got a bit of a push to actually focus on software development independently, because the guy that used to be my supervisor, he had studied computer engineering. He was so hard on architecture. So that's the code structure, how the code looks in terms of even the smallest part of code needs to be structured well, And that really pushed me. By the time I was still doing a bit of side projects while I was working, but I got into it more and more. And then with my wife, she would allow me at least to code at home, right? And then we started Top Code, and that was more in alignment with our purpose. So we sort of shifted away from corporate, and then until Top Code was founded 2018. And that's the brief introduction about myself and Top Code. And thank you for listening to me, guys. We can get into the business of the day, which is front-end, back-end, a connection between the two. So I have some notes with me here, just so that I don't forget. I'll try not to read by all means. But otherwise, the front-end is only just a fraction. And I understand this class is for Android development, right, which is part of front-end. So that then means from this slide here, the front end is just the small part, sort of small, and then the back end has all these services: back end, cloud storage, user authentication, push notifications, and hosting, right? So that's what we're going to be talking about today. And just an overview. Right now, I got a brief that you guys have built your apps, Android, and I'm assuming that the architecture is on point, right? So I can just maybe give a little bit of a lecture on architecture. Well, not a lecture, but just an explanation. And I would say that architecture is like, let's say, when you have a project, right? And a client comes to you and say, let's do a phase approach. We want to build this, let's say, e-commerce app. And then you start with a basic level of things. That way you can really put everything together really quick. But if you look at it, let's say like earphones, for instance. If we just start laying down 2 earphones, you can set them down whichever way. If everyone want to come and get them, untangle them, it'll be easy. But when the project grows, right, it's like there's more earphones now, and the way we're putting them is just randomly. Now, in the future, 10 years down the line, we want to untangle them. It's going to be a mission. So that's the same way with architecture. So that then means if we are to focus on the structure of the code, separation of concerns, what the different parts of the code does, put them everything together. That means even going forward, anybody that can come and try to read the code will understand. And there's a joke that I recently saw about how a programmer is coding, and in the comments it's like, by the time I coded this, only myself and God knew what this code does. But now, 5 years later, it's only God that knows. It's in the comments. Maybe there's even comments on what this code does, but it's not well architected. That means everyone will struggle to find out what this code does, right? So that, I would say, is the importance of architecture. And then, yeah, we can even maybe have a bit of a bigger picture look at architecture. This image that I've put here talks about the overall application architecture. So overall, that's our architecture where we have the physical data centers where the data is, right? Where our databases, our backends are running, and then we have networking, which is now where we're gonna be sort of talking about today, connecting the app to the backend, as well as operating system that would be hosting the backend, as well as the database management tools, and the cloud-hosted applications. So I believe that's where we are in this class, right? We are not really cloud-hosted applications, but we are more on the mobile application side of things, right? Yeah, so then there's the question, why would one need to connect backend to frontend, right? And this question can come mainly because, it is possible to have an app that just works on its own. You don't really need to be able to connect to a backend or any external system. You can have all the data in there, but when I was planning this lecture, I just came up with these 3 reasons. First one being data manipulation, the second one security, and the third one being multi-platform. So with data manipulation, what you want to do is to have a place where you have full access of the database. So that's best done in the back end. So you want a backend that does everything and then exposes just a little bit to the app or to any system that is consuming the API or that is communicating with the backend. And then, for instance, you might need to do even further processing on the data that you have. So you don't want to directly access it from the app, And what other point do I have here? So further processing would mean push notifications, cloud storage, or external services integration. An example of external service integration would be, let's say your application, still in the e-commerce example, right? You want to process payouts to pay the retailers that, they've gotten orders and orders have been delivered. So you want to automate all of that in the backend, somewhere where it's external to the app and it's much more safer or secure. Which brings us to the second point, which is security. So if we are doing everything in the app, we have the question of, is the app really secure? There are ways, to secure the code in terms of nobody can crack the APK or the build of the app, right? So that they don't get access to the code. There are ways to do that, but it's advisable to have a backend that deals with, the sensitive information, the sensitive data. So security is important. And lastly, the multi-platform. This is where now you want to sort of build with the future in mind. Yes, right now in this class we're building mobile apps, but there's a class that's also building iOS apps, for instance. There's a class that's building desktop applications, websites. So you want to have a central place where the data sits, and the heavy lifting of the system is really sitting on the back end. So as much as you can connect, let's say, to a Firebase database, Firebase storage from the app directly. But if ever you were to introduce different platforms, that would mean you would need to do that for all of them. But if you had a back end that deals with everything, then your apps or your different applications, they just have one thing to do, which is to consume the APIs, to connect to the back end and get all the data. So that would be the reasons, right? So, please excuse me for this slide. I just put it in this morning so that I had forgotten this part. So this would be how do we then connect the app to the backend. And I just wrote some notes here. And please do apologize. I do apologize the fact that I am not going to go too technical, right, in terms of how we actually do this thing. I'll talk of the concepts. I believe you guys we'll find a way to actually solve for X, right? So how we connect, we use HTTP clients. We can go for native HTTP clients that Android provides. So we can do that. That would allow us to define a backend URL, right? Where we then say we want to focus, this is the base URL, and then these are the different endpoints. For instance, endpoints for getting users, endpoints for getting, let's say, weather details, all these different kind of endpoints. And the second part here, I'm just mentioning these are libraries, right? DIO and OKHTTP. I know Android native there is a library called OKHTTP, which is quite simple, so you don't have to really go into the in-depth of how the HTTP client works. So OKHTTP, a library like that. There are other libraries as well that you guys can use, to connect the backend to your apps, right? And then native libraries, as I mentioned before. And then while doing this, you will need to consider the fact that calls need to be asynchronous, as well as maybe using coroutines. I don't know if you guys use Kotlin or Android native Java.
We're using Java.
Java. Yes. So okay, maybe coroutines would probably be like a plug-in into Java, but it allows for you to have asynchronous calls. This then allow for, when you query for data from a backend, right, you sort of have to wait for the data to come back. It could be maybe network speed that could delay you, or any other thing, right? Or maybe the processing on the backend. So you want to have a call that has that await, So Android has a lot of ways to do that. There's running background, where you make a call, wait in the background, maybe on the front end you show a loader, so that when the data comes now you can display it. So that, and then the other point I put there as well is caching. What you might want to do for the speed of your app as well is caching API calls. For this, you can configure manually caching or use a library for caching. That will allow you to sort of store the results of an API call, right? Let's say you're getting a list of users from the backend, so you would cache that so that every time you hit that API call, you immediately get results that were cached from before. And then the caching, you can configure caching so that even when it returns what was there before, it can check if the data is updated, for instance. And if the data is updated, you can load the new data. I think you guys will see this in most social media platforms, both Facebook, Twitter. They work sort of even offline because of caching and maybe local storage that they use. So those are some of the things that you might want to consider. Especially we're in South Africa, we can't ignore the fact that sometimes our networks are a bit slow at different places, right? And now we can explore the different ways of connecting the apps to the backend. So this part, I don't know, you guys will ask me if you have any questions, but I just sort of go into a bit of details in terms of the backend, in terms of services that provide different ways of having like a backend, right? And the options that are available. Let me just move with my slides as well, my notes. The first one, Google Cloud / Firebase. This is most likely what you guys, I believe, will use. And Google does offer like a wide range of, sort of on-the-go services, like Firebase storage, Firebase database, what is it called? I think Firestore. AWS has a lot of services as well. All these are fully fledged cloud services providers, and you guys can use them whichever way. There's Microsoft Azure, Roku, and these four at the top, they're really sort of platform or infrastructure as a service. So what they provide for is that you can have your backend code written and you just deploy. They already provide ready-to-use platforms to put the code and run. So you don't have to worry about configurations, hosting, all those things. And they also provide nice scalable solutions, right? And then in the bottom here, I have Python, Node.js, Golang, and Java. So these are some of the languages that you would use to write some scripts for the backend, and there are frameworks. So for instance, for Python, there are two frameworks that I wrote here, Django and Flask. Django REST. So this would mean that using these frameworks, you can write your backend codes, expose certain endpoints, have some processing of data. Let's say you want to have data that is sorted, that is done in a certain way, with your database. You connect to the database and you do whatever that you want and you send it back, expose APIs for the app to consume, right? And then Node.js, there's Express.js, which is a framework as well. For Golang, there's an interesting framework called Gin. I don't know why it's called that, but Revel as well for Golang. And then for Java, there's a Spring Boot, Spring MVC, and I believe J2EE, which is Java Enterprise Edition. So all of these options, all these languages you can use to sort of configure your backend, right? And please, I don't want to, overload you guys with information. And if you guys are interested, just choose one of these, right? I would, for one, go for Python. Python is sort of big these days because of its capability with AI. You can write a lot of stuff, machine learning stuff with Python. So you can maybe have a look at one of the frameworks for Python, which are Django or Flask, and see how you guys can set up a small backend to use and connect your apps with. And with that, for instance, you can use I know AWS has a service called not Cognito. I forgot the name, but I think it will come on the next slide. But you can use that service, and then you put your Python scripts there. That will be like your backend processing, and then you can really start connecting. So yeah, in this next slide, I sort of break down between plug and play and scalable solutions. And my understanding in this class, Android dev, and you guys are doing your project, and what you will most likely go for is plug and play solutions, like Firebase database, Firebase storage. And the good thing about Firebase, for instance, is that they provide SDKs that you can use natively on Android. So that would allow you to access the Firebase database directly, access the storage directly. That then means your app now, all the data is not just sitting in the app, If there are images that need to be uploaded, they're uploaded to Firebase storage database, Firebase database, which obviously will create an issue, in an environment outside of here where now maybe you need different platforms, But for this particular use case, that will work. There are services, there's a service called Backend as well. So Backend allows you to do sort of minimal configurations as to what kind of data you'd like to connect to on the backend. You can sort of create a table, even using drag and drop, I believe. You can create a table, let's say, of users. That users will look like this, and from your app, you can create sort of a model of how a user object is and send it through to Backend. Atlas is a service for MongoDB, and it's also like a database as a service as well, quite similar to Firebase database. And then AWS DynamoDB, that's also a database that has SDKs that you can connect directly to. And now, the scalable solutions. And the reason why you would want to have scalable solutions is when now you guys are now, have started engaging clients. I assume that all of you guys would one day probably want to start your own business where you service clients, build software, I don't know. But when now that's the use case, you want to have a system that can scale, that can handle large amounts of data, and obviously having separation of concerns, meaning that the app does one thing, the backend does one thing, another system does one thing. So this would be now things like functions as a service. And Firebase does offer that, so it's called Firebase Functions. It allows you to write scripts, what I was saying about, AWS Lambda, which allows you for Python and JavaScript. Firebase Functions just allows for JavaScript. So this first option, Functions as a Service, might be a bit limited in terms of the providers that offer it, like Firebase and AWS. It's limited because the language, Firebase is just JavaScript or Node.js. AWS Lambda is just Node.js and Python. So if ever, let's say you wanted Golang, you might have to either look for a different service or try to find like a new platform to build or to put your functions. So this, like I said, allows you to just have scripts that you put somewhere on that cloud service, and then you can easily consume without having to worry about hosting, with your backend sitting, all of those things. And then the next part, which is platform as a service, and we go again to these cloud providers, AWS, Elastic Beanstalk. So this one now is a bit bigger than functions as a service. It gives you a bit more control. It gives you an environment where you can actually install certain tools, let's say to run Golang, to run Java. So you can really play around, be more free, decide what to integrate with, You can even have multiple languages on the same system. You can have a Java backend, some scripts on Python that can talk to each other. And another example for Google is Google App Engine. It also provides platform as a service like that. Yeah, I don't know. Are there any questions, guys? Because I know I'm just doing a monologue. Okay, but all right, I'll continue. So here I just put REST APIs. So in essence, most backends are built using REST APIs, and REST stands for representational state transfer. And what REST is an architecture of how backends work, right? But it's not the only architecture. There are other ones like SOAP. And the difference between the two is that SOAP uses XML. Usually your responses, when you get data from the backend, it will be in XML format. It's really used in big corporates, and maybe it was built a long time ago, because now a lot of corporates are actually moving to REST, which sort of allows for different kinds of data to be sent through. It could be XML, it could be JSON, or any other formats. And JSON, I believe, is the one that's mainly used, where you can consume quickly and easier. And I believe Android also gives tools to sort of convert JSON into objects that you can use within your apps, So I just put it up there just to give that sort of explanation. So questions? You guys have no questions, right? Okay, cool. So I can continue. And that was really the main part about connecting to backend from the app. The next part is really sort of freestyling, going, tech trends, for instance. So you guys are doing third year, I believe, and you're probably wondering, what are we gonna do, after this? What's out there? There is Android development, there is front-end development. That's what we do at Top Code. We mainly do apps, websites, APIs, enterprise systems. But otherwise, what are the tech trends that are out there? So I just put a few: AI, machine learning, crypto, fintech, agri-tech, all these kinds of things that are upcoming that are quite nice, There's a lot of talk around smart cities as well. Those kind of things are things that are quite interesting. Big data, analytics, But otherwise, the importance of all these things is, especially in this context, is where would the code sit? If we're talking about machine learning, where would you put that code? Let's say you want to have a system that sort of diagnoses a skin condition. Where would your model stay? Where you train that model to say, well, okay, these pictures of people that don't have a skin condition, these ones have a skin condition, and you want it to predict sort of when you give it new data, right? So there's that question. And for machine learning, you can have in-app machine learning models, that you sort of might need to write a bit of C++ code. You guys are using Java, right? So you might have to go even deeper to use C++, even Python in your apps if you have these models internally. It's a bit cumbersome. So that then means usually you need to do that on your backends, right? Even, if you want to deal with crypto, you want to have that sensitive data that deals with currency exchanges and transactions. Apps like Luno, for instance, right? They have all that sitting on a backend, and the app is really a consumer of all that data, And in this slide, I put the access to information / globalization as a tech trend. I mean, as much as we can talk about all these nice things, where the technology is going, we do have to come back to globalization, especially us who are here in Africa, And the reason for this is because we still need to sort of have a net that encompasses everybody, We are here in Gauteng where the network is fairly okay, but there are people where I come from in Venda, Limpopo, or other places in Africa, where there isn't that much good network, even if there is any, So we need to have globalization as a tech trend so that we make information accessible to people all over the world. And there are apps, for instance, that are going data free. There's an app that I see a lot on LinkedIn. It's called the Moya app. What it does, it went quite basic. It went back to what WhatsApp does. So it's not anything really innovative or anything. It's normal chatting with anybody, right? But what they did, they went to these network providers and say, can you make this data free? Obviously there are fees that they pay, but they pack the app with a lot of features and functionalities, just so that at least there's a model to make money even out of when people are not really using data, right? So that's what they did. And the other thing that we need to consider in this context of Android development is app size. As much as we might want to put a lot in our apps, but app size is very important. Usually people will not download an app over 20 megabytes, And right now we're talking about regular guys that maybe the size of the phone is 1 gigabyte, for instance, right? So we need to have that in mind when we're building, to have the end user in mind. So that's why I have that there. And now I suppose we can move on to, let's see, to this slide, which is really just some charts. And I got this from Offerzen. Offerzen is like a sort of a recruiting company. I don't know if you guys know about it, but what it does is it sort of has communication with companies that would like to hire. For instance, if we wanted to hire, we go to Offerzen. Offerzen puts our use case, a job spec, everything in a good way, and then on the other side it connects to developers everywhere, and developers sort of have like an easy access to apply for jobs. Quite similar to LinkedIn, except it's focused on developers or guys in the tech space, right? So they recently released what is called the State of the Developers in South Africa, like State of the Nation, except it's like the State of Developers. And this chart here is like the tech trends, as I was saying. So you see your things like AI, cloud technology, fintech, crypto, cybersecurity, IoT, robotics, agri-tech, gaming, augmented reality, e-commerce, climate and sustainability, and cannabis tech. I don't know what cannabis tech is, but these are the things that are sort of trendy these days, right? And this is maybe where you guys, you've already set your minds into Android development, but if ever you guys want to explore, I believe this would be quite helpful. And then I have another chart here that just talks about the different frameworks that are quite desired by most developers. It's not what people are doing, but what's desired. And this would be determined by, for instance, what companies are looking for. When there are projects, let's say for freelancers, what are these guys looking for? What are companies looking for as solutions? And we have React, which is a JavaScript framework for websites. We have Angular, also JavaScript for websites. Flutter, it's a framework for mobile apps. And I know we're in a native Android class, but I am compromised. We use a lot of Flutter in our apps that we do. And I think the main reason is quick go-to-market strategy. Because it's Android, iOS, desktop websites. I like Flutter a lot. Otherwise, we have React Native also for cross-platform Android, iOS, Node.js, Backend, Vue.js, also Backend and websites, AngularJS, websites, and backends, I think. Django, as we mentioned, the Python framework, ASP.NET, which is dealing with a lot of Microsoft services, right? So yeah, that's what's up there. And now this chart here makes me sad a little bit. Well, not a little bit, a lot actually. And especially on this side, on my left side. And the reason for that is because if we check the gender inequality in terms of tech, that tells us that we need a lot more women in tech, you know. And there are two ladies in the class today, you know, actually more than men, yeah. But that's good, you know, we need more women in tech. And I'm very happy that I found it, or we found it, Top Code with my wife. And what we've tried to do is engage with NGOs that actually push for women in tech, and we sort of give out internships as well as, you know, train them as they come so that they can actually, we can have more women in our tech spaces. The places that I've worked at, right, in corporate, for instance, F&B and APSA, all those things, right, there's very few women. If anything, it's usually, let's say, one lady in a team, and otherwise it's usually just men, you know. And I'm not saying anything bad about these guys. I mean, probably they are trying to push for more women in tech, but I think this is something that we have to consciously consider. Even you guys, when you know you've gone into a place where you can influence others, you will push more women to be in tech, you know, because we do need to cover everything. And then on the other side, you know, as black people, I think we are catching up to white guys, right? And we still need a lot as well, especially given the demographics as well of the country and the continent. We still need more black people to be in tech, right? And that takes me to the next screen, which I literally just wrote, tech activism. So part of my, I don't know, my purpose, if I can call it that, is to campaign for tech activism. For instance, women in tech, more black people in tech. And the reason why this is important is the fact that, yes, we do have, for instance, a lot of tech companies, right? There are a lot of software dev companies, and one might even say that there's saturation in front-end development, apps, websites, desktop systems. There is a bit of saturation, but we need to get to a point where the playing field is sort of equal, right? And we have more players from the different demographics coming in, and therefore we need to be consciously tech activists to get more people. For instance, where my wife comes from, right? I went there, I did computer science and all, but all our cousins, now our cousins, right, their cousins, what they were doing or what they were sort of aspiring to study was things around engineering, things around economics, accounting, which is fine, right? I'm not against any of those things, but very few of them, right, knew about programming, what programming is exactly. And this is a small town, like a farm town, and it's really concerning, right, that there isn't a lot of information out there about what programming is all about, and therefore more people need to get in. So we need to be activists and get people interested. And yeah, I think this is my second to last, if not the last slide. You know, I've been going on. I don't know if you guys have any questions. Okay. But yeah, these are other topics that I just thought maybe I can just touch on. And some of them, you know, you suggested.
Yeah, I think the key one is the publishing, right? You guys also publish an app. So that's a key component of the POA project.
Yes.
So you might just want to kind of just give them a highlight of the procedure of doing it. How do they get to take their app from Android all the way to have it published on more apps or something like that. So because that's a key component in the next assignment. Yeah, so I think that's the major one I'll look at. Then I think the last one is the graphing one. Yeah, I think those two, maybe if you can go even a bit more technical on those two. That's fine.
Okay. All right, no worries. So with publishing, right, just on the high level of it, what is important these days is the privacy. You know, all these laws, the POPI Act in South Africa, the GDPR, I think, in Europe, and all these other ones around the world. It's really sensitive, you know, how we deal with people's data, because people will register, people will share their credit card details, all these things. So they are important. And for Google Play Store as well as Apple App Store, they are very sort of strict. You need to disclose everything. If your apps, for instance, take the user's location, you know, whether it's a fine location or the cause location, like sort of a general area where you are, you're gonna have to disclose what exactly you want to do with this information. Do you wanna maybe just show users malls that are around them or schools that are around, or do you wanna use them for tracking purposes? And they actually literally ask that, you know, do you wanna track users? So you have to disclose that no, we don't wanna track users, all that we want to do is this. If you are tracking them, let's say for instance you're building a system like Uber, you might have to track a phone, right? So you also need to disclose properly that no, we are taking this data for this. So yeah, with the request of going a bit technical, I think I can go to the App Store, and I don't know which app I can use. But okay, let's go to this app here. So this app, it's called Catch a Ride, that we built I think around 2019. It's like an in-house app that we built, and my wife Lerato came with the idea, and the app is around hitchhiking. Like there's a lot, well, I come from Limpopo up there, right? And there's a lot of guys that use public transport, and sometimes when they don't want to use public transport like buses or taxis, what they'll do is post, they have groups, like massive groups on Facebook, that would be around even 30,000 or more people, that would be saying, well, hey, I'm traveling on this date to this place, you know, and people can hitchhike. So we thought, okay, let's build an app like that. So Catch a Ride, it's live on the App Store, you guys can download, but it's not that used. As you can see, there's like 99 active users. You know, we haven't been pushing it that much, but otherwise, this dashboard keeps on changing over the years. But for Google Play, there is a fee that you will have to pay when you sign up, but that's quite small. It's around 300 rands, and it's once off. That's a good thing about Google Play, and that's in comparison to Apple App Store. For App Store, you pay $99 a year. Also not that bad, you know, it's around 2,000 rands per year. And yeah, it's a continual fee that you need to pay. For what reason, I'm not really sure, you know. But yeah, I think what's also important is, let's see.
So I think they're at a stage where they've done their development in Android. So how do they go about getting to
here?
Yes, I think that's quite
important. Okay, yeah, maybe the step that I can say I've skipped is, you know, putting your app together into like a package. And before, let's say like just a year ago, an APK was fine to upload to the Google Play Store, but now they don't allow APKs anymore. You have to use a bundle called AAB. It's an app bundle, right? And what that does is sort of enables you to have your app size as small as possible. Because I think they were fighting against APK. What it does, it bundles everything up together, like for the different architectures of phones and all that, and it sort of bloats the whole build, you know. So now with these bundles, app bundles, they are quite smaller and they can be sort of focused, and you can even have multiple app bundles for your app if it has so many features, you know. So if a user wants a certain feature, they might have to download a separate bundle separately when you already have the app, you know. So you will have to build that, and once you've built that, right, at this stage you've signed up. It's not a complicated process. If you guys have like a Google account, for instance, you can go to Google Play Store console, Google Play Store console. You register, you pay the fee that needs to be paid, you know. After that, I think where you need to go first would be in the main store listing, where you just need to have a bit of a description of what the app does. And it's not that strict, I can say. And where it's a bit strict, it's on the sizes now. The app icon needs to be, I believe, 512 times 512. And then feature graphic needs to be a certain size. You can see here 1024 times 500 pixels. And then screenshots. These need to be a specific size as well. And this applies for both Google Play, Apple App Store, as well as Huawei App Gallery. So those are the things that I can say are a bit cumbersome, but if you're really serious about it, it's not that much. You can actually, from your emulators, all the screen sizes that you want. If you open your emulator and take a screenshot from the emulator, you can upload that. Let's see. I believe that's pretty much it in this section. We can maybe go to the part now where you would upload your builds, APK, not APKs, but app bundles. So, what's this? So we can go to production, but what they offer as well is testing. So right now, what you guys might actually start with is testing, where you sort of can have either closed testing or open testing. Closed testing is when you just have a group of focused people where you would like to just share this build through a link, right, from Google Play, and then they can download the app and test. Otherwise, if it's open, you can sort of imagine like a bigger crowd of people that you invite, and then they can test as well. And what you will need to do is create a track, and then invite people, and then create a new release. And a new release is really uploading the app bundle. This is the part where you upload your app bundle. So from the Android side, I think I also forgot to mention this. Your app bundle or your APKs, right, would need to be signed. By signing, it's like sort of putting your signature in it. Yeah, like a normal signature, I suppose. So to create a signing certificate, you need to enter your details, address, locations, business, if it's a business, all those things, and you can have a key. There's a key that you will need to use to sort of secure that certificate so that nobody else can claim that they built this app or this bundle. And that's important because when you are publishing for the first time, next time you create a build, it will need to be signed with the same key. That sort of allows for, if there's an app, that's available, nobody can just come and say this is an update of that app. So it sort of creates that security. If we know that if there's an FNB app, it's been signed by FNB, and every time there's an update, it's from FNB. We're sure that nobody's going to try any funny things. So apps or bundles that are uploaded from here need to be signed with a signing certificate. And how we do that, there are certain commands that allow us to do that. Or even Android Studio actually does allow you to do that. You can go to, let me see if my Android Studio is open. So I still do a lot of dev work as well myself, right? But otherwise, it has the build part where you can say build signed build or APK, something like that. Something that will not take too long. But that's in essence how you would create your builds. I believe you are here. After this is done syncing, if I come here, it won't be grayed out, but generate signed bundle / APK. So that's what, you guys will need to go. And it will just tell you the whole process of generating the signing key itself and how you enter your passwords and everything. So that's how you create that build and then come all the way back to the website where you can upload the bundles. And after that, it will automatically fill out the release name. That release name is what you've mentioned on your Gradle file. Okay, this is still loading, but otherwise, on your Gradle file where you enter the version names, where you mainly put your dependencies, the inner Gradle file, that's where you have your version or release name, and then just some release notes. If it's an update, you say no, this update includes this and this features or this and this fixes, right? So that is pretty much it. The process after that, it's really about reviews. So when they review, okay, I guess what I didn't touch as well is that the whole privacy policy issues, who this app is for. Is it for kids? Is it for small kids? Which countries is it available at? And also with the reviews now, This was not there, let's say, 2 years ago, especially on Google Play, but they now require you to give out information. If you need to log in or sign in into the app, you need to give them, these are the test data they can use. They can sign in and then play around with the app. Even if, let's say, there are payment details, you can give them test payment details. And for Google, it's a bit slower these days. Once they introduce like a human reviewer, it sort of takes longer. But because Apple have been doing it for quite long now, their review process is not that long. So it will take, let's say, a day for someone to actually give you feedback. You might have a bit of back and forth, especially with regards to how your app uses privacy, people's privacy. Do you have like a new thing now is, can users delete their data from your app? Because when people sign in, you know, most of our systems, at least back in the day, we didn't consider how does this person now delete their data. You know, we see this in Facebook, for instance. If you want to leave Facebook, you can tell them, please delete my data, right? And you can even get that data. So apps these days, even though we are playing around with them, we will need to have that kind of information. But I think at this stage, they just disclose when you go to the app on the Play Store or the App Store, it will say that this app does not allow you to delete your data. So it will just at least inform the user, you know. Yeah, but otherwise, that's it. I don't know if you guys have any questions here. Please do have some questions on this part. Okay.
Sorry.
No worries, no worries.
Okay.
Yeah.
Are you guys okay?
Yeah.
I mean, you are free to publish to the other stores, but obviously this probably the cheapest, right?
Yeah, this is the cheapest for Android, yeah.
Okay.
Yeah, 300 once off.
Is it? Okay. Yeah, but I'm assuming the other ones, the cost is a bit high.
The April one, yeah, the costs are high, $99 a year.
Yeah.
And for Huawei, you know, you can publish to Huawei as well.
Yeah.
But for Huawei, it won't work with, if you have Google services like Firebase,
Yeah.
it won't work on Huawei's. But I'm not 100% sure the cost there.
Okay.
Yeah.
Alright.
Yeah.
I don't know, I've put the other guys online there. Can I say, you guys got any, can I say, you guys got any questions online there? On the publishing? No. Okay, yeah. Did you guys have any questions? Okay. Okay, if you've got any questions, just put them on the chat. Then we can try to answer them. Yeah. Okay. So I think this. I think as far as publishing, I can't think of
Any questions?
I'm just trying to. But obviously, if they're publishing, if you guys are just publishing for the duration of the assignment, right? Yeah, that's fine. I'll just check if there's any concerns on the money. Maybe I'll check to Susan to see how we can assist on it. You know.
And I believe they have one account,
Yeah.
you know, where you pay the fee, and then everybody can come and publish from there.
Yeah, maybe that could be a better arrangement so that we can, Okay, no, that's fine.
Yes.
Yeah.
Yeah, let me just wrap up.
Yeah.
Please move this up here. But yeah, I was coming to this point now of digitization, which is still around sort of the tech activism. But digitization comes in, especially here in Africa, South Africa, where a lot of systems, a lot of big corporates, including government, they don't have good digitization strategies, you know. And it's our jobs as developers to sort of have some form of excellence, you know, and concentration in what we do and digitize systems. Like I said, you know, some people or sometimes, you know, we can say that there's a lot of saturation in terms of software services that can be provided. What else can I do, you know? Everybody sort of wants to be cutting edge. Everybody wants to go analytics, AI, fintech, all those things. But with the problem of digitization, I believe that it opens up the space for everybody in the tech space, you know. That's why there's so many jobs out there. and even more can be created by us, as we have these solutions or ideas that we come up with for digitizations. The minds that are out there right now that have so many people employed, how are they leveraging digitization, And digitization would be from, let's say, automation of machinery and how we display that data, all the analytics that is coming from there. So that means then we have two sets of jobs, the analytics part, the gathering of data, and the display part, which is front end, which is what we do. So I believe that if we do that, especially if we do it with excellence, with architecture in the core, which is something that I like, right? Or, I value, we can really have systems that can impact people of the future, our children and our grandchildren as we grow, right? And this is important because, for instance, in our public schools mainly, there isn't a lot of digitization. If there is any, it's really not up to standard, and if we had systems that were really done the proper way, done with the proper architectures, we can really have a system that is talked about, and kids as young as 7 years old, they can always have that curiosity. What is this thing? What is this thing? And we'll get more people now that will come into the tech space. So therefore, with what we do, we always have to have that form of excellence so that the people around us will be asking, what is this? I also want to get involved. So digitization will sort of cover the left out market in our country, in our continent, just so that we are able to play play catch up. And at the same time, there will be others that will be going for this high tech trends and all that, which are very, very important, right? And the next part, native or hybrid. And I think that one is a tricky question, given the class Android dev. And my thoughts, it depends on what you want to do, right? In terms of, for instance, what we aim for is a quick go-to-market strategy. And for that, we do develop using Flutter, like I mentioned before. And I come from an Android native background. And I'm telling you, 2 years ago, or 3 years ago, right, you wouldn't have convinced me if you came to me and said that, let's build something using Flutter, or let's build something using React Native, something that's hybrid. So, and the reason for that was because you have so much control with Android native, with iOS native. You have so much control. You can interact with like the base operating system through C or C++, those things in native, right? Whereas hybrid, it's a layer on top of the native, and you have very limited control. But that said, there are platform channels as well, that you can use to sort of integrate. Let's say you want to manipulate the camera and you are using Flutter or React Native. You might have to go platform channels. Platform channels sort of allow you to write native code and expose it to a higher level architecture or framework like Flutter. Those are my thoughts. You guys can feel differently about it, especially because we are doing Android native. And then the last point, the graphing. So I was briefed by Dr. Kennedy yesterday that I can touch on graphing as well. And with regards to graphing, I can say that there are two options, right? The first option being developing the graphs from scratch, which is now you're going to have to be drawing from a canvas. Android does provide you with a library called Draw and Paint and all those things, and it really uses a canvas, right, as though it is literally painting. So it is it's a bit mathematical in that you will need to know where your x and y axis of the screen is. And if I remember correctly, 0 and 0 of the x and y is at the top left corner, of the screen, unlike at the bottom, bottom left. I don't know why, but otherwise that's the 0, 0. So if you're drawing a graph, therefore, you'll need to sort of pinpoint the data points, of the graph before you plot the actual line, if this is a line graph. So that's how you do it natively. It's a bit mathematical, but not too difficult. I think I've had instances where I had to sort of deal with that, drawing graphs or drawing around on top of a picture, those kind of things, and I do have a link here that I believe we can go to check it out. So this is graphs in native Android. So the graph that will look like this. Like I said, it will need to start with data points, where your data, has the different points. If it's let's say a yearly graph, you have in this year, this is how much, people are there, for instance, and then to draw those points. So maybe we can start here. This is using Kotlin, but I hope you guys, will see it's quite related or quite close to Java. But you start with a custom view class. So a custom view class, you guys will use maybe text view or all these other spinners or something like that in your XML, right? So a custom view class is a normal class that extends view. And inside that class, you will then have your paintings, or where you maybe can declare what kind of data points you guys want to have. And also here they have like a maximum and a minimum for the y-axis, also for the y and x-axis, And then you can have like a model for the data points. Your data point will need to have x and y so that we know where it is, right, in relation to the screen. And from that, you then can create the different data points. Where are my different data points? Let's see. Oh, okay, this is paint objects. So this would be sort of a set of details, for instance, the stroke width, the color, and the style. So this is now, let's say this particular data point paint is for the dot itself, and then you also have one for, let's say, line as well, and then the fill, and the line paint. So you also have, you need to declare everything that you use. So the paint for the lines as well as the data that you want to draw. And then if you go down, okay, we'll just go to where now we actually are declaring all these things. So this is the calculation that you need to set the data, setting the minimums, the maximums, and this can be in relation to anything, right? But I think what's more important is to know that at the top of your screen, on the left side, it's 0, 0. So therefore, the maximum of your x-axis will be, let's say, 100, the minimum 0. And then for your y-axis, the minimum might be, let's say, -10, and then 0 being the maximum, for instance. And then, you add the data sets. It validates, is sort of clearing everything and reprinting. And then drawing everything on a canvas. The code is a bit mathematical. If I'm being honest, I didn't really get into the nitty-gritties of what this is. But what I do see is, for instance, you will set up the data points, start for x, y, ends, and all that, and you draw. And then draw circles as well for the data points. These are the data points. And then now you will need to draw lines that connect the data points. So this is doing it natively, and I'm not sure if in this lecture you guys are doing that natively, but this is more...
Yeah, from our side, it's just native,
You're doing it, you're not using libraries or anything?
No, we can. I mean, you guys are going to use a library that makes it easy to draw it, but that's also fine. But
yeah, I mean...
Mm-hmm.
Yes, if you are using a library, this you don't really need to worry about. Yeah. This is if you want to like do everything from scratch. And in most cases, this would be where they would require you to build everything from scratch. Would be, let's say, at corporates where data is really sensitive, like banks, for instance. Because using a library that's built by someone, they're not sure if there's a backdoor where they can get people's data and all that. So in most cases, in these banking apps that we see, most components have been built natively.
Look, I mean, the graphs are not so complicated.
Yeah.
So I don't see a problem with using the native one because
Yeah.
we're getting some data from Tyrus.
Okay.
They just need to display some change. So they can do a pie chart, or you can do a bar graph, Just when the simplest of graphs they can do as well. Yeah, so it's quite open. Yeah.
Okay. Understood. And I had a video of like a library, one of the libraries, but it is an old video.
Okay.
So let's see. I won't play in full. I just skip to certain points of the video. But it really just talks about, this is maybe for like a line graph, and this library allows you to actually have different kinds of graphs, like you're saying that pie charts, bar graphs, and all that. Yeah. So the library itself is called. Okay, they're just so creating. Okay, yeah. So graph view. It's called graph view. So you guys can go and search graph view, and he is using like a jar file. You download the jar file and then you sort of import it into Android Studio. That way you don't really need to configure it on Gradle, right? But you can, I believe you can also get the Gradle link and put it, on the Gradle build file instead of using like a jar file. But otherwise, that's how you would now have that library in your app, so that you're able to use it in the XML, in your layout files. So, okay, this is when you're downloading it, and this is how you import it. I think you can play this part.
Yeah, you can put it on your phone.
Okay.
Right click on it, go down to add a library.
Yeah, you can try to
Open up your project and go up to this tab up here. Go to project, open app, and paste it into the libs folder. Okay, and then right click, so now it's in the libs folder, right click on it, go down to add as library, and okay. So now Gradle will sync and that library will get added.
Yeah.
No, you can.
Yeah. Okay. All right. Yeah, definitely. It will just show like how to now do the graph view.
So then you should be able to click on this and to see those. And that's it. So now the library is ready to go. So the first thing we'll do is go into activity main. We're going to create a graph here. So you just select this one, Jojo graph view, to match parent and match parent, so it consumes the whole layout, and just give it an ID, call it graph. Sure. So then if we go into the design tab, we can see that the graph view takes up the whole layout. So the next thing we'll do is go into main activity and start interaction code. So you can declare a line graph series of type data point. And we're going to call it series. We're going to declare some variables. So I want my graph to start at -5. So I'm going to put x equals -5 for my first value. There's a lot of customizability. I'm just going to show you.
I'm going to be sharing. I'm recording. I'm recording.
Easy sign block.
I'll also share
You can create
the
a
links.
function.
Yeah.
Like I'm actually making this tutorial because I just finished making my first app, a quadratic equation solver, and it makes a plot. So while this stuff's all fresh in my head, I like to do a tutorial, do a couple tutorials anyway. So then we need to make a loop to loop through all the data points and store them. So we'll do, I think this is 100 data points. So we'll do like 500. And 5++. So x equals x plus 0.1. I think if you go any higher than 0.1, then the graph won't look like it's continuous. So, and that's in my experience anyway. Like if I made this 0.5, there'd be sharp edges. So play around with it, and whatever works. I just found that 0.1 works pretty good. So we'll do a sine plot. So here's where you can put pretty much any function. Like I could call this 5 times x, or 5 times x plus 1, or whatever. We'll do a sine plot. So then you just append the data, your data point, you put your x and your y. And this number right here is the amount of data points in the series, so we have to match this number with this number so that you get the right amount of data points. And then outside of the loop, you just do graph.add series, series. And that should be pretty much it. Let's run this. So in the following tutorials, I'll probably do some customizability stuff. So like how to make points on the plot that will stand out, like a red dot at a certain point, or how to make multiple series plot on the same graph, stuff like that. Okay, so there you go. So you can see that it has a lot more. It starts at -5, because that was the initial x coordinate, and plot 500 points. So there's a quick little tutorial on how to use graphs with Android. So if you want to learn more about this, keep watching the next videos. Thanks for watching.
Cool.
Okay, guys.
Yeah, I think that's all for me, guys.
Okay.
I'll share these links with you.
Sure, no problem.
Yeah.
You guys got any questions?
Any questions?
You guys have any questions, especially on the project? I think it's quite clear. I know we're gonna touch up tomorrow, but
I have a question.
yeah.
Yeah.
Just give me a second.
Yes, ma'am.
With regards to